All right, I thought I would get this out as early as possible. This is as early as I possibly could, actually. So what I thought I would do is just kind of discuss each of the answers and not go too fast, but, kind of explain like what's going on in each step. So if you remember that if you have degrees here and you want to change it to radians, radians involves a measure that involves pi as 180. And so this is basically a conversion factor. And so since this is degrees, you want to introduce pi into the angle as a measurement. And so you would just simply reduce this as low as you can go. You get 31 over 18. And then 31 over 18, reduce it if you can. But if you can't, you can't. Likewise with this, you're just really reducing the fractions. I mean, if it's negative, it stays negative because you're spinning to the same location. You're just changing your measurement. It's like you're going from centimeters to inches. Okay. All right. Now, if you have the pi, then you want to get rid of the pi and then multiply by 180. So you're going to introduce degrees. So really, we should have degrees right there in all of these to be technically accurate, and then that way the actual unit will stay put. Okay. All right. So here, let's see. If you have a negative angle and you want to have coterminal angles, you are literally just doing a spin. You are spinning one direction or the other. So all you got to do is add 360 to get the positive one because this guy's negative. You can add 360 to get the positive and then subtract to get the negative. Sometimes you have to add 360 twice to get a positive. Just remember, a full spin just takes you back to the same location. So that's why these guys are the way that they are. Okay, now we're going to go into DMS form. And so all you got to do is the 56 is his own thing. Okay, he's going to stay there. But it's the decimal that you want to break up into pieces, or you want to take this percentage of 60. So 8.75 or 87.5% of 60 is 52.5. So now we got 52. So then you grab that last decimal and say, okay, well, what piece of that is in seconds? So 0.5 times the seconds will give you 30 seconds. So you're really just finding percentages, and whatever's left in the decimal place is what you use to get to these pieces. Okay, and now this kind of feels more like a clock measurement rather than a ruler measurement. Okay, likewise with here, if you want to take that decimal, now this is part of the answer already. Take that decimal, multiply by 60, take that percent. Here's your decimal. That 0.58 will go here, and then that is going to be your minutes. And then you can't go any further. Seconds. And you can't go any further than that, so you'll just round up. All right, just like with pennies or something. All right, now going backwards, this guy is 16/60ths of a minute, so he's that. So we've got this percentage of a minute is going to get added to here, but he is negative. So don't make this guy negative. You're going to keep him here just like that. You're going to, in fact, you're going to ignore the fact that he is negative. Then this 49 over this, because you are dealing with, you're going into minutes, and there are 3,600 seconds in a full degree. Okay, so if you want to go into seconds, you're going to have this ratio here. So that 49 over this is that extra that will be added to that, and then that gets added here. But notice that it doesn't care that this was negative. If you added this to a positive negative 184, you would get a negative 170, or you'd get a negative 18, like it would go in the wrong direction, 183, okay? So always keep these guys positive because you are going to keep going in the negative direction. All right, same process here. Divide by 60, get that. Take the seconds, divide by 3,600, get that guy, add those two together. That is what's going to be your decimal form, going from DMS to decimal. Okay, so now the length of the intercepted arc is always, what percentage of the circle are you on? Okay, and all that is a very easy formula when you have radians. It is just simply r theta. So r theta, that's it, and that's in feet. So they gave you the radius in feet, so that's what your measurement is going to be, okay? Likewise, this guy has to be converted to radians in order to multiply to him, and then your formula is very easy, okay? Area of a sector is half theta r squared. So follow that formula. Half theta r squared. Your theta in this case is 2 pi over 3, and your r is 4.1 miles. So half times theta times the radius. And that's just going to number crunch that, and you will get that. And that represents this entire area of that sector. That is a sector, okay? And here we go, 300 degrees, so make sure you convert this to radians, okay? Now this is 300 degrees pi over 360. That is an error, isn't it? This should actually be 180, right? Because a pi, unless you put 2 pi over 360, that's okay. But this is actually 300 over 180. So this is why this reduces to 5 pi over 3. So if you're wondering about that, that is that's pretty important there, because that's going to be 5 pi. Yep, that's right. So there's your theta, 14 centimeters squared. That ends up that. Take half of that. So that ends up being 5 pi over 6, etc. Multiply. There we go. Okay, so that would be confusing if I saw that in the answer key. Okay, we're not doing any of these. Okay, tangent. Looks like they use tangent here. We are looking from 64 degrees, so this would be an A, and that would be an O. Tangent uses that, so we would set up this ratio here, and you would end up with these two will just swap with each other. So 23 divided by the tangent of 64 is going to be that. However, if you are not in degrees, then this will be wrong. So you always want to make sure that you can navigate back and forth. Make sure that when you go to mode, okay, hit mode, and you can see radians and degrees. You might have to go back and forth several times on this test. So watch out for that. It's very, very important. They gave it to you in degrees, and that's normally what they do in geometry. When you get to trigonometry, we'll usually put it in radians. But for these triangles, because they're taught in geometry, we will usually keep this in degrees, okay? So here is theta here. So the cosine equals the A over the H. That is an A, that's an H. And in order to get theta, though, we would have actually had to do the arc cosine in order to get that, to solve for that. And that's going to give us 49.6 degrees. So you needed to make sure you were in degrees. If you were not in degrees, then you would have got like a, you would have got a weird decimal. Okay. In fact, I am in radians, right? Okay. So what is that? 49.6 times pi over 180. You would have got that, and you would have like, well, what is that? Well, that's a radian. So remember, that is basically a percentage of one radius. So you went around, I won't even explain it like that, but just watch out for that, because you want to make sure that you're in degrees when you're doing these triangle problems, and look at the multiple choice. Here is an O, and that's H, so we'll use sine. And if we want to solve for x, we would just cross multiply there, and that would give us 71. All right, whenever you have a ladder, that's always going to be the hypotenuse, because that's the thing leaning against something. And if the base is 17 feet away, they want to know what is the angle of elevation. So you're looking from down, you're looking up to get the angle of elevation. And this looks like an A over H, so they use cosine. Do the cosine inverse to get the theta, okay? If you want to undo this is kind of what you're doing here, okay? And remember, when you do this, you get theta. Remember, if you remember, the very last thing we learned last Friday was that you get theta if you do this. Just make sure you do it to the other side as well, and that's what we see right here. So that's a calculator thing. If you're in degrees, you will get degrees. If you are in radians, you will get radians, and the answer won't make any sense. Okay, now here is, let me actually stop here with this video and we'll start with 23 in the next.